Hey everyone, thanks for joining us online. YouTube, by the way, gets the stream first, so you're the very first ones to see me. And then it takes a second for Facebook to catch up, and I have to click a little button. While you're waiting for these 10 seconds, go ahead and hit like and subscribe, and that little notification bell thing. I don't know too much about YouTube, and especially about live streaming. I can hear myself, because I had my own computer ramped up volume. That was glorious. All right, so feel free to type questions into the live chat, either Facebook or YouTube. But it's time to get this show on the road, isn't it, Greg? All right. Where are my notes? Here they are. And live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about a big planet near a little star, and a guide to making the giant telescope that you've always wanted in your backyard, but the city wouldn't allow you to have it. And of course, we're taking listener questions about all things, because this show is about the entire universe. We record the show every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. In today's Blue Shift, I'll be talking more about the power of steam. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent of the stars. We've got an exciting show for you today on Space Radio, where we talk about all things space, astronomy, astrophysics, rocketry, science, and society. If it's above the Earth's atmosphere, and even if it's in the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus, so call 888-581-0708. Get those calls in. You can also follow along on our YouTube live stream and Facebook live stream. There are links at spaceradioshow.com. We'll take questions that you send there too. Hello, Gustavo is following us on YouTube. Giving a nice little shout out to one of our live stream viewers and all the others. Send your questions to me. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. There's a new planet that's discovered, which, okay, fair enough. New planets get discovered all the time. That's one of the most exciting areas of modern astronomy is exoplanets, extrasolar planets, planets outside of the solar system. And what we're finding year after year, even day by day, in this treasure trove of planets that orbit other stars, we are finding so many ridiculous, crazy sci-fi fantasy style planets out there. It's going nuts. It's beyond our wildest imaginations. Case in point, the planet known as NGTS 1b. NGTS stands for Next Generation Transit Survey. It's a planet hunter telescope. And this particular planet, is the size of Jupiter. It's about 30% the radius, or 30% greater the radius than Jupiter. So it's bigger than Jupiter. So it's a big honking planet. That by itself isn't too exciting. We know of lots of stars we know of lots of planets that are bigger than Jupiter. But it's orbiting a star. It's orbiting a star that's about half the size of the sun. It's orbiting what's called a red dwarf, a small dim star. And the question is, what? How? When we think of how solar systems form, if there's a lot of material in a cloud of gas and dust that's going to collapse and form a stellar system, then the star will be very, very big because there's lots of material, and its planets will also be very, very big because there's lots of material. But here we have a case where it's a little rinky-dink star, a little puny star, even smaller than our own sun, and it's orbited by this way out of proportion planet. It just doesn't It just doesn't make sense. And we don't have good models. We don't have good understandings of how systems like these form. It's just the number one reason why we don't have a good explanation for systems like this is the first one we've seen. And so we don't have a lot of observations. We don't have a lot of data to make progress on understanding solar systems like this. But it's just the extreme variety of exoplanets, of planets outside our solar system, is something to behold. It is just amazing. We never know what the next month is going to bring when it comes to planets outside of our solar system. And this is just the latest example. It's not even the most extreme or weirdest scenario. It's just the latest weird thing we've spotted orbiting another star, a way giant planet orbiting a tiny star. If you have any idea of how a system like that could form, give me a call and we could write a paper together, okay? Because this is totally active research. And remember to call 888-581-0708 to tell me your ideas of how planets like this could get around little stars like that, or to ask me your own question. That's the latest and greatest when it comes to space. I do have another little bit of space news that I'll get to later, but right now it's time to have a conversation. All right, on the line, we've got Bill. Hey, Bill, thanks for calling Space Radio. Where on earth are you?
Hi, I'm in Columbus, right here with you.
Oh, that's great. I hope you're not like right here with me because there's no one else in this room. Greg is over in the production booth. I see him. But you're very close to me in both space and time, which is nice. What is your question about the universe, Bill?
My question is, if everything started in a fraction of a millisecond and blew out from there, why is the universe not contained on the surface of an expanding sphere? Why does it look like there's things that had a 300 million year head start on us?
This is a very, very deep cosmological question. It's an excellent question, Bill. And there is a big conceptual leap you have to make when you're thinking about the whole entire universe, and especially the Big Bang. It's important to remember, and for the record, I'm not a great fan of the term Big Bang when it comes to our model of the understanding of the history, especially early history of the universe, because when you say Big Bang, you conjure up an explosion, like there's a boom somewhere over there, and that's not right. That's not the right mental model. The Big Bang is not an explosion in space. It's an explosion of space. We live in an expanding universe. Every galaxy is getting further away from every other galaxy. And if you run that back to the very, very distant past, then everything was very, very close together, had a very high temperature, and had very high density. And that is what we call the Big Bang. So your question of why isn't everything splatted on the surface? Well, one way to actually think about it, and this is totally going to break your brain, and because it breaks my brain, it breaks everybody's brain to think about this. You can, if you're feeling creative enough. We live in a three-dimensional universe, right? 3 spatial dimensions. Can we agree on that?
Yes.
Okay, good. You can imagine our three-dimensional universe is the surface of a 4-dimensional sphere. And that 4-dimensional sphere is expanding, and we're riding along on the surface, on the 3-dimensional surface. The same way if we lived on the 2-dimensional surface of a balloon, and the balloon was expanding in 3 dimensions, and we were riding along on that 2 dimensions. You can do that if you feel like it. You can build... Go ahead, Bill.
I say you are breaking my brain.
Okay, good. That is exactly why this show exists, because I get a distinct pleasure out of confusing people and then trying to enlighten them. There is that follow-up. So it's like boot camp, but for cosmology, the study of the universe. We got to break you down before we can build you up. And I swear, I can't fit it in my head. I can't exactly imagine it. The answer I usually like to go to resolve this is to appeal directly to the mathematics. And the mathematics of an expanding universe says, yes, you can take our three-dimensional universe, embed it in a higher dimensional structure, and view it that way, but you don't have to. But you don't have to. We live in an expanding universe where every galaxy on average is getting further away from every other galaxy, and that's it. Our universe has no center. It has no edge. It might be embedded in a higher dimensional structure, but it doesn't have to be because the mathematics are very clear and simple. Simply, every galaxy on average gets further away from every other galaxy.
That helps.
That helps. I'm glad I could help. Thank you so much for calling, Bill. It was great to chat with you. That was such a powerful question. I love these very deep cosmological questions about the nature of the universe because there's so much jargon tossed around. There's so many little quips, just little succinct phrases that are tossed around in discussions about astrophysics and astronomy and cosmology, the universe, and that really, these are jargon terms that we need to expand, that we need to inflate a little bit, that we need to set up what we're really talking about when we discuss things like the expansion of the universe. And one of those things is Big Bang. So we're going to take a quick break, folks. Don't forget to call 888-581-0708 if you want to join the conversation or catch the live streams on YouTube and Facebook. And I see all of you on YouTube and Facebook. Don't worry. And I see some interesting questions that I'm going to get to later. But it'd be so great to talk to you on the phone. So call 888-581-0708. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Go to patreon.com/PMSutter to learn how you, yes, you can support this show, yes, this show with your individual donations. It's such a cool system. Patreon.com/PMSutter is how we pay the bills to make this broadcast possible. So go to that website, patreon.com/PMSutter to learn how you can support the show. You can also follow me directly on Twitter and Facebook if you feel like it. My name is @PaulMattSutter because that is my name. We're going to take a little break. See you in a little bit. I saw an interesting questions up there. Someone's asking about beer in the solar system. I don't think I'm going to... Flying Spaghetti. I saw it. Where's... Here we are. All right, there's some good questions here. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got some questions on our live streams, especially discussing that bit of news that I shared about a big planet around a little star. And John Michael Gaudier, who we had on the show a couple weeks ago, was wondering if it could have been a captured planet. So maybe, because of the oddity of this situation, maybe it didn't form this way. Maybe it came later. Maybe this little star formed, it was minding its own business, and then out of nowhere came this massive planet and was captured by this little star and put in orbit, and we just happen to see it now. And that is certainly possible. I honestly don't know if that's plausible or not, because for a little star to capture a massive planet like that, that's going to be a little bit challenging gravitationally. It's going to be a little bit challenging of just the probabilities of interactions. Of course, this is the first time we've seen a system like this, so maybe it's actually kind of common, and we just haven't noticed it yet. And now is our first example, our first entry into the wonderful world of captured exoplanets. My gut says maybe not, that it's more likely an odd situation of how this system formed in the first place rather than a capture scenario. But that's an excellent idea, John Michael Gaudier. It's an excellent conception, and certainly planetary capture happens. somewhere in the universe at some rate. We just don't know how common it is. I saw some other questions on the live streams today, especially talking about the speed of gravity. And there's this very interesting thought experiment that you can do. We all know about the speed of light, right? Light is fast, but not infinitely fast. It takes time for light to travel from A to B. And we're kind of used to that fact by now. We've got a good handle on it. For a couple hundred years now, we've been measuring the speed of light with pretty good reliability. Now, the question is, let's say tomorrow the sun blinked out of existence, just no more sun. How long would it take for us here on the Earth to notice? Well, the light takes 8 minutes to go from the surface of the sun to here on Earth. So if you're blinking on if you're squinting your eyes on a sunny day, if you're tanning yourself on the beach, the light that's hitting your eyes, hitting your skin right now, actually left the surface of the sun 8 minutes ago. And it traveled through the vastness of space between the sun and the Earth. So if the sun were to blink out of existence, it would take 8 minutes for us here to know on the Earth that the lights suddenly went out. But what about gravity? In the old Newtonian picture of gravity, the gravity you learn in elementary school and even high school, gravity is exchanged instantaneously. Gravity happens right away. Gravity happens right away. So in the Newtonian picture, in the world of gravity as envisioned by Isaac Newton, the Earth's orbit would be disturbed immediately as soon as the sun winked out of existence, before the light even arrived. In fact, we'd just go flying off in a straight line and be ejected from the solar system. That seems like a problem, doesn't it? That seems like, why should gravity be faster than light? Why should we know ahead of time with gravity something that is going to take light 8 minutes to catch up? And the answer is provided by Einstein's general relativity. Einstein's general relativity replaced the Newtonian picture with a much more sophisticated view of gravity. And in this sophisticated view of gravity, gravity takes time to propagate from one place to another. It will actually take the effects of gravity 8 minutes to go from the sun to the Earth. So if the sun were to wink out of existence, we wouldn't know on Earth, both from light and from gravity, we wouldn't know for 8 minutes. So excellent questions and discussion on the YouTube live stream about those questions. Feel free to join along on the live streams. Go to spaceradioshow.com for the links. And you can also call 888-581-0708 to talk to me on this recording. You can get your voice on air. I don't know if that's an incentive or a discouragement. It depends on your personality, but we take all kinds here on Space Radio. So however you like to ask questions or have a discussion about space, the universe, science, and society, we've got you covered. Now, this other bit of news that I caught, I like big telescopes, all right? And I cannot lie. We've been doing telescopes for like 400 years, right? Ever since Galileo took nautical telescopes and polished them, made them way better, pointed them up at the sky, saw the moons of Jupiter, saw the rings of Saturn, but he didn't identify them as rings. He just saw them as two lumps. He saw features and pockmarks on the moon. He saw the phases of Venus. It just opened up this world, this universe, this cosmos in a way that had never been seen before. And in the hundreds of years since Galileo, in order to do better astronomy, we've had to do better telescopes. And better telescopes means bigger telescopes, because the telescope is really just a giant eyeball. Your eyeball, your iris, is a bucket for light. It's a way for light to get in, and then the light gets focused so you can see it. right? That's like how an eyeball works. A telescope is a bigger bucket for light. It has a wider diameter and it has some lenses so it can focus it so you can resolve it. This means we can see very, very faint things. And the operation of focusing magnifies things. They look bigger. So we can see very, very far away things and we can see very, very dim things and very small things simultaneously. That's why telescopes are so useful. Nowadays, we like giant telescopes, and we're building a new classes of telescopes. There's 3 or 4 telescopes that are being built simultaneously that are in this realm of just super gigantic telescopes, the biggest telescopes that the Earth has ever seen. One of them is called the Giant Magellan Telescope, and it's going to be installed in the Atacama Desert, or in the mountains next to the Atacama Desert in northern Chile, one of the driest places on Earth, one of the clearest, darkest skies on the planet. This telescope is made of 7 different mirrors. Each one is a hexagon, and they're arranged in like a little honeycomb pattern. Each mirror is 8.4 meters across. That's like 25 feet. 25-foot wide mirror. To make these mirrors, each individual mirror is 20 tons of glass. 20 tons of glass that are poured into a mold, and then the mold has to cool for months to get it just the right. And then it has to be polished. It has to be polished and carved to within, what's this number? 25 nanometers. We're talking about an object, a precision instrument that's huge, 25 feet across, that is polished to an accuracy of 25 nanometers. That is ridiculously accurate, but that's what we need. Altogether, the Giant Magellan Telescope will be about 80 feet in diameter. And this telescope, along with some of its cousins like the 30-meter telescope and the European Extremely Large Telescope, which are going to be a little bit larger, but hey, once you're at that size, no one's really counting. This is going to open up the next generation of astronomy. So what we're looking for over the next 10 or 20 years is the universe as revealed by these giant telescopes. It's going to be a new thing, and I hope space radio is still going on in 20 or 30 years so I can talk about the universe that will be revealed by the new generation of telescopes. We're almost out of time today on space radio, but before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift. This is my chance to get a little bit closer to you. And last week I talked about STEAM and the power of STEAM. This is combining science, technology, engineering, arts, and math to just STEAM, to just cross-disciplinary research, cross-disciplinary outreach, the value of doing that. And it turned into a promotion for STEAM Factory at Franklinton Fridays, which is a very, very cool thing. And I hope you all went and had a good time and enjoyed the food and also the science and art. But I didn't get to the thesis of why I think it's important, why I'm involved in Ohio State University's STEAM Factory, why I think it's important to not ignore the arts when it comes to science. This is something I'm very personally passionate about. I recently was in New York at the Children's Museum in Manhattan, and I did a performance with a dance company. Siren Modern Dance did a performance based on quantum mechanics, and they invited me to narrate it, and it was a very, very fun experience. And I love combining science with the arts. From the perspective of a scientist, it gives me new ways to communicate what I know and love about the universe. It gives me new ways to express it, to have it resonate, to have it connect with people in ways that traditional ways of communicating science just aren't going to cut it. If I want to reach a new audience, if I want someone to understand how I see the universe and the beauty that I see in the universe, then working with artists is essential for me. From the artist's perspective, the sciences provide a new source of inspiration. It's new stories that we're surrounded by beautiful, poignant, powerful stories in the subatomic world, in the cosmic realm, at universal scales, in the physics and forces and energies and fields and particles of the world around us. There's so much complex interplay. There are stories to tell there, and artists can use that as inspiration. And so I've been very lucky to work with a few artists over my career who see this, who see the benefit, and we've made some very powerful collaborations that are always fun to do. And I will be sure to keep you updated on any new projects in the STEAM world that I might be engaged in. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. I can't say how important this is. Go to patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalka for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. You can call 888-581-0708 to join the conversation, and we can also connect on Facebook and YouTube using the live streams, which are now working rather well, I would say so, Greg. Isn't that right? Greg is nodding his head in enthusiastic agreement. You can go to spaceradioshow.com for all the links and all show notes, all episode archive, the whole deal. Once again, my name is Paul Sutter. Thanks again, Earthlings, for listening. See you next week. End of transmission. Thanks, everyone, for catching the live streams. Don't forget to like and subscribe. I love all the discussion that was happening over there. It's over here on my screen, but it's somewhere else on your screen. See you next week.